Hello students, you probably remember we discussed in class that the parent function exponential has different shapes according to the base that you take. So for instance, in this case, 2 power x, the black graph, will look a bit different from 3 power x and 5 power x, the other two graphs. That's all because you have actually used different base for your exponential function. So in this case, you probably think, it looks like the graph has been transformed somehow. However, in this case, it's not because of vertical stretch or horizontal stretch or anything else. It's more because the base is different. We also discussed in class and looked at, for instance, 2 power x and a half power x. That looks like a horizontal reflection of each other. So, however, when you look at the formula 2 power x and a half power x, there is nothing that shows any horizontal reflection, because you should actually see a negative here somewhere, right? Negative x when it is a horizontal reflection. But then we also already discussed in class that although this horizontal reflection in this case comes from the different base 2.5, we could also show algebraically at the time that 2 power x and the other one is a half power x, and we think that they are kind of like a horizontal reflection of each other, and algebraically we showed that that's all because we could write a half as 2 power negative 1, right? We learned about exponent rule in class, and then you still have that power x. So therefore, because of our exponent rule, we have power and power again, exponent again, we could like multiply them. So then we have negative x there. So then in this case, we have shown that here, although we see that the reason why the graph is a mirror image or reflection horizontally is because of the base that looks different, you can actually explain it also in terms of horizontal reflection. You see, you can change it into 2 power negative x. So similar to this, we are going to try now to explain how we could stay with only one base, which is used a lot in modeling using exponential function. The base we use will be base E, the natural number. You can think about it as if you think about pi. It's an irrational number, 3.14 blah blah blah. And E, it's kind of like a special number like that as well. The value is actually 2.178 and so on and so on. Oh, I think I do it differently. I think I do it wrongly. It's 2.7818 and so on and so on. Anyway, so we are going to use this as our base for our exponential function. So how can we actually explain this? Let's look at our result from the previous podcast when we say we use a different way. We use 2 points to find our formula, and we came up with 383 times 1.015 power x. Okay, and then now what we will try to do is to change this into base E. And how are we going to do that? So looking at the general formula for that one, for that previous function, we actually started from this general formula. Okay, now if we want to use base E, this will be the general form, the common general form that we use. So E will be a specific number already. It's not G, which is unknown. E is a specific number, 2.718 and so on. So we will actually include A horizontal stretch there. So this is the general form, the basic general form that we usually use. So when you look at this, you probably see the difference. I'm going to highlight that. In this case, if we want to convert G, which is any number, something that we have to figure out, and we want to be consistent with base E, we could see that then we have to find the value B such that E power B will be the same as or equal to G in this case. So from there, when I want to convert my base to base E, I don't want to use this 1.015. What I should do then is to figure out the value of B. So let me highlight that again. So this is what I want. I want E power B to be 1.015. So I will need to find this parameter B, which is actually the factor of your horizontal stretch. So let's try. I'll go back to pen again. So what we have now is that we have a base E, which is 2.718 whatever, and then power B should be equal to 1.015. Unfortunately, we do not have algebraic mathematical skill now because it will involve logarithm, and we have not actually done in class. However, we could ask help from our graphics calculator. With any equation, you can always do that. So the unknown in this case is this power here, this exponent of E. That's our unknown. So when we look at our graphics calculator, abs function, any equation you can solve by finding intersection between left-hand side and right-hand side of the equation. So I'll just put here the unknown is B, so we will just replace that with variable x, just because that's the unknown. And then 1.015 on the right-hand side. And I have used here a setup for the minimum and maximum value of x and y scale. That's what I have in my calculator. And then if I look at the graph, this is how it looks like. And to find the intersection, I will have to reopen my calculator just for a minute. So this is what we have now. And to find the intersection, I will go to function and intersection and say OK. So in this case, you see here, apparently the value of B here is a very small number, very close to 0. You see this standard form, 1.4889 times 10 to the power of -2. So this is actually a small number. When you write it as decimal, that will be, so decimal point 2 to the left, 0. So B is 0.0149 to 3 significant figure. So let's check one more time. 0.0149 to 3 significant figures. So that should be fine. So then in this case, if I want to write my original blue formula to base E, I should write it as y equals 383 E to the power of 0.0149 x. So that's more or less what we could do if we want to stick to base E. It's not a must, actually. This is just an introduction. that there is this kind of function where we stick to a natural number. In your own project, you do not have to do it. You may, if you want to try that. But next year, you probably will be required to use base E when you are doing exponential function. So this is a kind of introduction to what could happen next year. So hopefully you enjoy it and have fun trying to find formula for your population data. Good luck.